Hey guys, welcome back to our channel Learn Together. In the last video, we discussed about data types, comments, and keywords in Python. In case if you have missed it, you can check it out in the description below. In today's video, we'll cover operators in Python. So let's get started. Operators are the symbols used to perform a specific operation. There are several types of operators such as arithmetic, assignment, relational, logical, unary, bitwise, and membership operators, which we'll be discussing in detail in today's video. Now let's talk about arithmetic operators. They are used to perform basic mathematical operations including addition, subtraction, multiplication, division, and many more. Let's understand this with examples. So for addition, print 2 plus 3. The answer is 5. Let's run and see. Here it is. Let's see for subtraction. It is similar to addition. Just write print 5 minus 1. Instead of plus, you can use minus for subtraction. Run it. So the answer is 4. Similarly, for multiplication, 7 into 4. Click on run, 28. For division, 15 by 3. Click on run. See, the output is 5. There are some other operators as well, like modulus. Modulus is used to print the remainder of two numbers. So print 10. This symbol is mod 3. So the remainder obtained when 10 is divided by 3 is printed here. So what's the answer? 1. So let's see. See, this is the output that we got. If you would like to find out the power, for example 2 to the power 3 or 2 cube, how can we write that? Print 2. You have to use 2 stars here for finding the power or exponent. Star 3. So 2 to the power 3. What is the answer? 8. So let's run. See, this is the output. You can also perform integer division. That means the decimal part is eliminated. For example, print 15 by 2. See, if we perform division, what will be the answer? 7.5. 7.5. So if we want to perform integer division, that means decimal part should not get displayed. What should we do? We have to perform integer division. Okay, one more slash. You have to add one more slash. Let's click on run. This is the answer. Only the integer part is displayed here. So this is all about arithmetic operators. Next we have assignment operators. These operators are used to assign values to the variables. X is equal to 9. Print X. Here the value of X is printed. Like we have discussed in our previous videos, the value 9 is assigned to the variable X, and that is what is printed here. X is equal to 10. Y is equal to 15. Print X to print the value of X. Print Y to print the value of Y. So 10 and 15 are printed. We can also combine these two lines and write it in a single line. X comma Y is equal to 10 comma 15. So the value of X is 10 and the value of Y is 15. So let's see whether the output changes or not. Click on run. See, the output is the same because the value of X is 10 and the value of Y is 15. Here the value of X is 20. When I say X is equal to X plus 1, what happens? X is equal to X. What is the value of X? 20 plus 1. That means X is storing the value 21. Let's run and see. So 21 is printed. Okay. You can also write a shortcut for this. This is same as x is equal to x plus 1. Let's run and see. So yeah, we got the same answer. Because x plus is equal to 1 is the shortcut for x is equal to x plus 1. Similarly, you can write the shortcut for subtraction as well. X minus is equal to 2. Print x. So what is happening here is x is equal to x minus 2. That means the value of x is 21. So 21 minus 2, which is 19, should get printed here. Let's see. So yeah, we got the answer as 19. You can try other arithmetic operators by yourselves. Moving on to relational operators. These are used for comparison. For example, a is equal to 25, b is equal to 32, print a less than b. So what is the answer for this? Is 25 less than 32? Yes, so the answer is true. Let's click on run and see. Yes, the answer is true. In the same way, print a greater than b. Is the answer true? No, the answer is false because 25 is not greater than 32. So the answer is false. So to check whether a and b are equal or not, how do we do that? Print. You have to check whether a is equal to b or not. So is this the right notation? No, because this is used for assigning, right? So how do we check whether a is equal to b or not? By using double equal to. Click on run. The answer is false because a and b are not equal. Now, how do we write the condition for a not equal to b? Print a not equal to b. This is the notation we use for a not equal to b. Is a and b not equal? Yes, the answer is true. So it is true. Now, how do we check two conditions at once? Less than or equal to, greater than or equal to. How do we do that? For a less than or equal to b, we use this less than equal to. We use two symbols, less than or equal to b. Is this true? Yes, because a is less than b. A is 25, which is less than 32. Click on run. So the answer is true. For checking whether a is greater than or equal to b, we use greater than first and then equal to b. Click on run. So it is false because a is not greater than or equal to b. Now let's learn about logical operators. These are used to test more than one condition. X is equal to 5. Print x greater than 3 and x less than 10. What is the output? Is x greater than 3? Yes, 5 is greater than 3. Okay. Is x less than 10? 5 is less than 10. Yes, even this is also true. So true and true. What should be the output? It is true. Let's run and see. True. So for and, what should be false? So false is nothing but 0, right? 1 is nothing but true. So false and false. What should be the answer? False. False and true. It is false. True and false. It is false. True and true. It is true. So and is true. The outcome is true only if these two are true. Both the conditions are true. Only then the output is true. In other cases, the output is false. That is the truth table for AND. Now, what is the truth table of OR? False or false? The answer is false. False or true? It is true. True or false? It is true. And true or true is true. The outcome is false only if two conditions are false. In other cases, the output is true. Now, what is the truth table of not? For not, it is the opposite. If it is false, then it should be true. And when it is true, when we apply not, the answer should be false. Simply the opposite. Now, what is the output of this? Or x greater than 3. X less than 2. What is x? 5 less than 2. Is 5 less than 2? No. False. Or x greater than 3. 5 is greater than 3. This is true. False or true? From the truth table, what is the answer for false or true? It is true. Let's see. Yes, the answer is true. Because for or, if any of the condition is true, then the answer is true. Now, what is the output of this? X greater than 3. X is 5. 5 greater than 3. Yes. So, true. Not of true is false. Not gives the opposite of the condition, right? So, the answer is false. Next, we have unary operators which are performed on a single variable. X is equal to 2. Print minus x. See, as x is equal to 2, minus x will be minus 2. So what is the answer for this? It is minus 2. We have other unary operator which is plus x. That means it is same as x. What is the answer for this? It is minus 2 because x is minus 2. Plus of minus 2 is minus 2. Moving on to bitwise operators. These are used to perform operations on binary numbers at bit level. Print see, what is the answer for this? The binary value of 5 is taken, the binary value of 3 is taken. And the AND operation is performed on both the binary values. For 5 and 3, what is the binary value of 5? 0, 1, 0, 1. What is the binary value of 3? 0, 0, 1, 1. Right? So when we perform AND, 1 and 1. See, 1 is nothing but it is true. 0 is nothing but it is false, right? So, 1 and 1 is 1, 0. Here it is 0, 0. So, what is 0, 0, 0, 1? What is this? It is 1. So, what is the answer of 5 and 3? It is 1. Click on run. See, the answer is 1. You can check it for or also. 5 or 3. For or, the output is 7. For not, what is the output? Let's see. It is minus 6. Negation of 5. See, in Python, the size of integer is 32 bits. So, what is the binary value of 5? It is 0, 0, 0. Like that, we have some number of zeros, and the last 4 bits are 0, 1, 0, 1. As the size is 32 bits, so there are number of zeros in front of these 4 bits. Okay. So we all know that negation of 0 is 1 and negation of 1 is 0. Simply negation is the opposite of this particular value, right? So what is the negation of 5? It is 1, 1, 1, 1, 1 because these all are zeros, right? The last 4 digits are 1, 0, 1, 0. Okay, so this probably is minus 6. That's what is printed there. Lastly, we have membership operators which are used to test if a sequence is present in an object. Let's say x is equal to hello in X. Okay, let's run and see. Yes, the word hello is present in X, right? So that answer is true. Let's say print Python, not in X. Is Python present in X? No. So the answer is true. That's it for the video, guys. Don't forget to like, share, and subscribe to the channel for more exciting content. Thank you for watching.